Hi guys, in this video we're going to go over some basics of factoring, and this video is going to be all about quadratics, which you have done before. So the very first thing you want to look for when you go to factor is a greatest common factor. So that means any number that you can divide all of the coefficients by. So in this case, if I'm looking at 4, 2, and 16, I see I can divide them all by 2, and that will be the biggest number that I can divide them all by. If you notice, they also all have the variable x. Now this only has 1, so that's the most that I'm going to be able to divide by. So 2x is the greatest common factor. So when I factor that out, that goes out front, and the leftovers go back on the inside. So 4 divided by 2, and then take away one of the x's. 2 divided by 2, take away one of the x's. 16 divided by 2, and that x is gone. So that's what it would look like. All right, so when you're done with that, you look at what you have left to factor and decide if that is quadratic or cubic. You can tell by looking at the exponent. This is quadratic because the exponent is a 2. So every single quadratic that can be factored gets factored into 2 binomials. So it should look like x plus or x minus, just one other number in the parentheses. All right, so 2 types. The first type is a difference of 2 squares. So difference means it has to be subtraction. It doesn't work if it's plus. And square means that an exponent is even, so we can divide it evenly into 2. And you can take the square root of whatever the numbers are. So here I have 4x squared minus 9y to the 6th power. It's subtraction, which is good, and my exponents are all even. So I can do a difference of 2 squares. So what I like to do, I just like to make a box. I just think boxes, when factoring, are a good way to check. So this box has to be 4x squared. This box has to be negative 9y, 9y to the 6th power. And then these 2 boxes have to cancel each other out. So they cancel each other out because they are the exact same, except one has to be positive and one has to be negative. So first start by breaking up the 4x squared. I can take the square root of 4, and that's 2. And if I break that in half, right, it basically boils down to 2 times 2 and x times x. All right, sorry guys, I had to pause the video because my cat was like scratching the table. So what that means is this is going to get broken down into 2x times 2x. That's the perfect square. I broke it down evenly so that the factors are exactly the same. All right, I'm going to do the same thing with the 9y to the 6th power. If I take the square root of that, the 9 becomes 3 times 3. And I just need to split that in half. And that's why the exponents have to be even, so that you can have the same exact thing for both parts. So this will be 3y cubed, 3y cubed. All right, one of them has to be positive, one of them has to be negative. It doesn't matter which one is which because they're the same until you do that step. All right, and this is why I like putting it in the box, because now I can multiply this out and check and make sure that it actually works. So if I multiply the 3y cubed times the 2x, that's going to give me 6xy cubed. And if I do the same thing for the negative 3y cubed and the 2x, that's going to give me negative 6xy cubed. And that's perfect because that equals 0. When you combine those, they'll cancel each other out. So this final answer is 2x plus 3y cubed, 2x minus 3y cubed. That's the factored form of that. All right, so again, it has to be subtraction. The coefficients have to be perfect squares. Your exponents have to be even. And as long as those criteria are met, you can factor it like this. All right, the next one is a trinomial. Now I'm purposely doing one with a number in front of x squared because it's way easier if that's gone. So we're gonna do most of our examples when we have that leading coefficient. First, I'm gonna check and see if I can divide these all by 2. That would make my life easy, but I can't. What I like to do first is multiply the first term and the last term together. So that's gonna give me negative 12. All right, and here's why people a lot of times struggle with factoring, because you are maybe trying to do this quickly, which is not always the most efficient. You need to find factors of whatever that number is. And I like to list all of my factors out so that I know those are my only choices. Factoring is a lot of guess and check, but it's easier if you have it organized. So 1 times 12, and then I just go in order, 2, 3, 4, 5, 6, and I skip any integers that don't go in evenly. So 2 times 6, 3 times 4, and then after 3 is 4. I already have 4 on this side, so that means I'm done. My answer is in here somewhere. All right, now the fact that this is negative, if this sign is negative, it means that your signs are, no, scratch that, not that one. This one, sorry. I'm looking at the wrong thing. If that last sign is negative, the only way to multiply and get a negative number is if one of them is positive and one of them is negative. The signs have to be different. So I'm looking for basically a subtraction. Which pair, when I subtract, will give me negative 11? So I know if I do 1 minus 12, it multiplies to negative 12 because the signs are different. And if I combine those, I get negative 11. All right, so there's like a little shortcut that I do. It's shorter than making a box. The box is more efficient because you can check it. So I'll do the shortcut way here, and then in class we'll do some with a box together. So the quick way is to ignore the 2 for a second and just use the pair that we found. So x plus 1, x minus 12. Now obviously this is not the answer, and here's why I don't always love this shortcut, is because a lot of students think that from here they're done. X plus 1 times x minus 12 would be x squared minus 11x minus 12. That's not our original problem. So we're not done. The last step of the shortcut is to take whatever that leading number was, so in this case it's 2, and divide those numbers by 2. Whichever one you can't simplify and you can't divide, that's the factor where the 2 is going to go in front of the x. So in this case, it's the first factor. 1/2 does not simplify. 1/2, like 1 divided by 2, is not going to give me a whole number. So I call this the bottoms up. That 2 is going to go from the bottom up in front of the x. So that turns into 2x plus 1. All right, now my other factor I can simplify. 12 divided by 2 is 6. So simplify if you can. 12 divided by 2 is 6. All right, now that is my final answer. And if I multiplied that out, it's going to work. 2x times x is 2x squared. 2x times negative 6, there's my negative 12. 1 times x, there's my 1. And then 1 times negative 6 is where the negative 6 comes from in the original problem. All right, so the first day that we do factoring in class, we're going to focus on the quadratics.